Okay, so moving on to our next chapter, that is operations on rational numbers. So what does operations means in mathematics? It is our addition, subtraction, multiplication and division. Now in 8th standard, all of you are well versed how to do addition, subtraction, multiplication and division, right? I don't need to teach it again. How, like what is 2 plus 3 is equals to 5. It will be very silly, right? But still, I've seen many students to make mistakes in these two concepts when these operations involves a negative number. So for example, let's take a number 2 and let's take another number minus 3. So what is 2 plus minus 3? It can be written like this: 2 plus minus 3, which means 2 minus 3, and the answer will be minus 1. Fine. So basically, let's take a number a, which is a positive number, and a number minus b, which is a negative number. So always a plus minus b is in the form of a minus b, which means basically what we are doing addition of a positive number with a negative number. So it will come out in the form of a minus b. The second thing which students make most mistakes in, a minus b. So what is it? Basically, if suppose for example, if I take a again as 2 and b again as minus 3, so what is the subtraction of these two numbers? So it will be a minus of minus b will be plus, so it is a plus b. So basically it will come as 2 plus 3, which is 5. Okay. So the next part which will be useful in this chapter and in doing question is how to compare fractions. How to compare fractions. And this also I believe all of you have done in your previous classes, but still we will quickly revise them. So suppose if a fraction is there which have the denominator as same, let's say 3 by 7 and 5 by 7. All of you can easily tell me that 3 by 7 is less than 5 by 7, right? So if the denominator is same, we can easily compare the fraction. The higher the numerator, the higher will be the fraction. Because just imagine something like this. There is a piece of cake and you have made 7 parts of that. So someone is getting 5 parts out of it, another one is getting 3 parts out of it. So obviously the one getting 5 parts is getting the higher amount of cake. So 5 by 7 is greater than 3 by 7. But what if the numerators and as well as the denominators both are different? Let's say let's take a fraction 3 by 4 and 5 by 6. 3 by 4 and 5 by 6. Now the denominators are different as well as the numerators are different. Now how to compare these two fractions? To do this, if we compare this fraction into its equivalent form, that is, and this fraction also in its equivalent form, such that their denominators become equal but the value of fraction does not change. What I mean to say is that suppose if I multiply the numerator and denominator of this fraction by the same number, that is 3, and if I multiply the numerator and denominator of this fraction by the same number, that is 2, am I changing the values of this fraction? This fraction is still 3 by 4 and this fraction it's still 5 by 6, because see what it will become. 3 into 3, that is 9, divided by 12, we can again cut it by 3 and it will become 3 by 4. So basically if we multiply numerator and denominator by the same number, we do not change the value of the fraction. So 9 by 12 is same as 3 by 4 and 10 by 12 is same as 5 by 6. So this fraction is basically 9 by 12 and this fraction is basically 10 by 12. So now when we have made the denominator same, we can easily say that 9 by 12 is less than 10 by 12, right? The higher the numerator, higher will be the fraction, given that the denominator is same. So in turn, 5 by 6 will be greater than 3 by 4. Fine. I hope all of you have understood this. But now the next question comes. How does this come in my mind that I have to multiply this by 3 and this by 2? See, our aim is to make the denominators of both these numbers, both these fractions as same, right? 12 and 12. Thus, does 12 appears in the table of 4? Yes. Does 12 appears in the table of 6? Yes. But suppose if I went on to make 4, if I went on to do something like this, 3 into 2 upon 4 into 2, right? So it will become 6 by 8, which is equivalent to 3 by 4. But my denominator is becoming what? My denominator is becoming 8. So, and 8 does not come in the table of 6. So how can I make this denominator into 8? It is not possible, right? So we have to think about LCM. What we have to think? We have to think about LCM, least common multiple. Least common multiple of 4 and 6. What does least common multiple means? That a number which comes in the table of 4 as well as in the table of 6, and it should be the it should be of least possible value. See, we could have taken 24 as well, because 24 also comes in the table of 4 and 24 also comes in the table of 6. But why we are not taking 24? There will be no difference in the answer. But what is the benefit of making our number larger and larger? So that's why we always have to think about the least common multiple. Least common multiple of 4 and 6. Let's take another example. Minus 5 upon, let's say, 9 and minus 4 upon, let's say, 8. Fine. So which one of them is the larger fraction? Fine. So again, the denominators are not same. Let's think about the LCM. What is the LCM of 9 and 8? The LCM of 9 and 8 is nothing but 72, the multiplication of 9 and 8, right? So to make 9 into 72, you have to multiply 9 with 8. So the same time I will multiply my numerator also with the same number. So it is minus 5 into 8, it is minus 40, right? And 8 into 9 gives us 72. So I will multiply my numerator with 9 as well. So minus 4 into 9 is minus 36. Now out of these two, which one is the greater fraction? Denominator is same, we have achieved that, fine. Now compare the numerators. Which one is bigger, minus 40 or minus 36? As we have learned in the previous chapter, minus 36 is bigger than minus 40, which means this fraction is bigger than this fraction. That means minus 4 by 8 is bigger than minus 5 by 9. Fair enough? I hope all of you have understood this. And what if the numerators are same? It is very easy. What if the numerators are same? So if the numerators are same, let's say the numerator of two fractions is 5 and 5, and denominator is, let's say, 8, and here the denominator is 9. Now if the numerator is same, it is very easy. If the numerator is same, it is very easy to compare. Like when the denominator was same, it was very easy to compare. The same way, when the numerator is same, it is very easy to compare. Now we are dividing 5 by a greater number here, that is 9, and we are dividing 5 by a smaller number here, that is 8. So higher the denominator, the lesser the fraction will be. Higher the denominator, the lesser the fraction will be, because 5 divided by 9, we are dividing it by a larger number in comparison to 8. So this fraction will be smaller, that is 5 by 9 will be smaller in comparison to 5 by 8. So if the numerator is same, if we have to compare two fractions in which the numerator is same, the greater the denominator, the lesser will be the fraction. Greater denominator, lesser will be the fraction. And if numerator is different and denominator is same, greater the numerator, greater will be the fraction. I hope this was all clear. And if the fractions are different, if both the numerator and denominator are different, try to make the denominators of both these fractions as same by thinking about the LCM. Multiply the numerator and denominator of this fraction by some number such that both the denominators become equal and the value of the fraction will not change, and you can easily compare between both of them. Now we have to understand the meaning of two terms in this chapter, which is, the first of them is multiplicative inverse. Multiplicative inverse or reciprocal. The same term is also referred to as reciprocal, and I hope all of you understand the meaning of reciprocal, right? So multiplicative inverse or reciprocal means the same thing. And what does this mean? Suppose if I have a fraction, let's say 3/4, with what another fraction should I multiply it such that the answer comes out to be 1? So that means x will be called as the multiplicative inverse or the reciprocal of 3/4. So it is, I think, obvious enough that the answer will be 4/3. So the reciprocal or the multiplicative inverse of 3/4 is 4/3. Let's take another example. What will be the multiplicative inverse of -4/5? It will be, as all of you must have guessed, it will be -5/4. Because if you multiply -4/5 with -5/4, the answer will be 1, right? And negative into negative becomes a positive. So the multiplicative inverse of -4/5 is -5/4. And my friends, please note that it won't be 5 divided by -4. This notation is incorrect. This notation is incorrect because there is a rule in mathematics, and please note it down in your notebook, that there is a rule in mathematics that we do not generally keep negative sign in the denominator. Even if you encounter something in which negative sign is in the denominator, please always consider that the negative sign is written with the numerator. We do not ever keep our denominator as negative. So instead of writing it as 5 upon -4, we should write it as -5 divided by 4. And let's take one more example. What will be the multiplicative inverse of 7? What will be the multiplicative inverse of 7? Won't it be 1/7? Because 7 into 1/7 is 1, right? So multiplicative inverse of 7 is 1/7, and vice versa is also true in this. The multiplicative inverse of 1/7 is 7. Okay, because both these numbers when multiplied with each other will give the product as 1. Okay, and the second term which you will encounter in this chapter is your additive inverse. The second term that you will encounter is your additive inverse. What does additive inverse means? Additive inverse means, suppose let's take same type of fraction 3/4. With what fraction or number should I add 3/4 with such that the answer is 0? So x here will be -3/4, isn't it? So additive, basically, let's take another example. What is the additive inverse of -1/7? Now additive inverse of -1/7 will be 1/7. So additive inverse means adding a number to another number such that the sum becomes 0. So the first number will be called the additive inverse of the second. What is the additive inverse of -2? It will be 2. The additive inverse of -2 will be 2. What is the additive inverse of 2? It will be -2. This goes both ways. What is the additive inverse of -4.5? It is +4.5. What is the additive inverse of +4.5? It is -4.5. So it goes both ways. You have to just add a minus sign in front of the number whose additive inverse you want to find out, and that will be the answer. I hope all of you have understood this. Now let's move on to doing some questions. So here in the first question we have to do multiplication of two fractions, which is -25/62 into 31 divided by -75. So let's see what will be the answer. So it is minus 25 divided by 62 into 31 divided by minus 75. Now we can cancel minus and minus sign because minus into minus is positive, they cancel each other. And 25 into 3 is 75, right? And 31 into 2 is 62, right? So what we are left with is 1 by 2 into 1 by 3, which is 1 by 6. This is our answer. Okay. Now let's move on to the second question. Now please pay attention that here it is the division of two fractions. Here it is the division of two fractions. And as all of you know, division of two fractions are always in the form of a by b divided by c by d, and which we can write it as a by b into d by c, right? So here 55 by 90 is divided by 11 by 45. So I have wrote it in the form of a by b divided by c by d. So it will become 55 by 90 into d by c, which is 45 by 11. Now 11 into 5 times is 55, and 45 into 2 is 90. So we can cut these number as like this, and the answer will be 5 by 2. Fine. I hope there is no doubt in this. Now let's move on to our third question. Now here we have to do subtraction of two fractions, minus 18 by 20 minus 12 by 17. Fine. So for this we will need to take the LCM of 20 and 17. Now the LCM of 20 and 17, 20 is 4 into 5 and 17 is a prime number. So the LCM will come out to be the multiplication of both of them, which is 340. Okay. And so basically what we are doing, we are making as we did in the comparing the fractions, we are trying to make the denominator as same. So the LCM is 340. I have multiplied 20 with 17 to make 340. So I will have to multiply minus 18 with 17 as well. So minus 18 into 17. Okay, minus 18 into 17. And this will come out to be minus 306. Minus 17 into 18 is minus 306. So it is minus 306. Now this minus sign will come here, minus. Now I multiplied 17 with 20 to arrive at 340, right? So I should have to multiply 12 also with 20. So what is 12 into 20? It is 12 minus 240. So the answer will be minus 306 minus 240. So basically it is the addition of 240 and 306 with a minus sign in front. The answer will be 6, 4 and 5. The answer is minus 546 by 340. I hope all of you have understood these three questions. So now let's move on to question number 4 and question number 5. So question number 4 asks us, which is the smallest rational number out of these given options? Which is the smallest rational number out of these given options? What if I tell you that we don't have to do anything to solve this question? See, we all know negative numbers are smaller than positive numbers, isn't it? So out of all these numbers, see, 0 divided by 5, the answer is going to be 0. 1 by 3 is a positive number, 10 by 2 is a positive number, 9 by 4 is a positive number. The only negative number that we have over here is minus 7 by 3. So directly we can say that the answer is going to be minus 7 by 3. See, in objective type of questions, objective type of question means where the answer is already given, there are 4 options and you have to choose the answers. So please always keep your mind open and see that can you directly answer the question without doing any calculation. This will save your time in the examination. So by doing some intelligent, just by having some presence of mind and doing some intelligent thinking, we can, without any calculation, we can directly say the answer is going to be minus 7 by 3. Understood? Now just for comparison's sake and just for practice, let's compare them as well. Suppose for practice, let's do this. Let's eliminate our 0 by 5 and let's make this a positive number, 7 by 3. Fine. Why did I eliminate 0 by 5? Because this answer was going to be 0, and if I made this number as a positive number, then out of all these given numbers, obviously 0 is going to be the smallest one. So I have eliminated this number, I have made this a positive number. Now suppose this would have been our original question, how can we do this? So to compare, as I taught you, we have to make the denominators as same. So what is the LCM of 4, 3, 2 and 3? Just think about it. What is the least number which comes in all their tables, in their multiplication tables? The answer will be 12. Because 12 comes in the table of 4, 12 comes in the table of 3, 12 comes in the table of 2, and 12 is the least number that comes in the table of all these three numbers, that is 4, 3 and 2. Okay, so basically to make 4 as 12, we have to multiply it with 3. So we should multiply the numerator again also with 3. So 9 into 3 is 27. Okay, now to make 3 as 12, we are multiplying it by 4. So we should multiply the numerator as well with 4, so that the value of fraction does not change, and 7 into 4 is 28. Now to make 2 as 12, we are multiplying it by 6. So 6 into 10 is 60, and 1 by 3, again if we are making 3 as 12, we are multiplying it by 4, and 1 into 4 will be 4. Now as we have made all the denominators as equal, we can directly compare the fraction which has the greatest numerator. Obviously 60 is the greatest numerator, so the greatest fraction out of these available 4 fractions would be 60 by 12, that is 10 by 2. And obviously what is 10 by 2? It is 5. 7 by 3 will be 2 point something, 1 by 3 will be less than 1, and 9 by 4 again will be 2 point something. So obviously 5 will be greater than all of these numbers. So the answer is 60 by 12, which was equal to 10 by 2. Fine. I hope you have understood this. Now let's move on to our next question, that is question number 5. It is a very simple question. You have to again do subtraction of two fractions and see how simple it is, because the denominator is already same for both of them. So if denominator is same, the LCM is going to be that as well, that same number, that is 192. So we can simply do the subtraction. So 145 minus 83. Now what is 145 minus 83? It will be 145 plus 83, because minus into minus will become plus. Fine. So the answer will be 192 will come in the denominator. And what is 145 plus 83? 5 plus 3, it is 8. 4 plus 8 is 12. 2 and 1 carry over. The answer will be 222 by 192. But see, we can still simplify this fraction because both of them are even numbers. We can cut them by 4. So if we cut it by 4, so it will come as 57. And what will come in the denominator? It will become 4 into 4 is 16. The remainder is 32. It will come as 48. Now 57 by 48, can we further simplify it? Yes, both are multiples of 3. So 57, if we cut it by 3, it will become 19, because 19 into 3 is 57. And 48, if we cut it by 3, it will become 16. So our final answer will be 19 divided by 16. Let's move on to the question number 6 and question number 7. Question number 6 asks us, what is the multiplicative inverse of 6 by 2? So as we have learned earlier, it is very simple. Multiplicative inverse of 6 by 2 will be 2 by 6. That is the reciprocal of 6 by 2. And 2 by 6 simplified is 1 by 3. So the answer is 1 by 3. Now let's move on to the question number 7. So question number 7 is basically the addition of two fractions, and the denominator of the answer is already given to us. and we have been asked the numerator. So let's do this question. Again, we will have to take the LCM. What is the LCM of 15 and 18? It will be 90, right? Because 90 comes in the table of 15 as well as in the table of 18, and this is the least number that comes in both of their table. So 15 into 6 is 90. So basically we have to multiply 12 also with 6. So 12 into 6 is 72. So it will become minus 72 plus. Now see, now please note that there is a negative sign in the denominator of this fraction. This fraction is written as 13 upon minus 18. So basically this fraction, the equivalent form of this fraction is minus 13 by 18. So instead of writing a plus sign over here, I should write a minus sign over here. I hope you have understood this. See, I earlier told you that there should not be a negative sign in the denominator. We have to transfer it to the numerator. So plus minus 13 will become minus 13. So now 18 into 5 is 90. So what we have to do is 13 into 5, which is 65. Fine. So the answer will come out to be 90, and the addition of 72 and 65 with a minus sign in front of them. So 5 plus 2 is 7 and 7 plus 6 is 13. Minus 137 by 90. But in the original question, the denominator is 270 and not 90. Now what should we do? Let's multiply both the numerator and denominator by 3. Let's multiply both the numerator and denominator by 3. So 90 into 3 will become 270. That is what we wanted. And now what is 137 into 3? So 3 into 7 is 120. 3 into 7 is 21. 1 and 2 carry. 3 into 3 is 9. Plus 2 is 11. 1 again and 1 carry. 3 into 1 is 3, and the carried 1 minus 411. That's our answer. So what should we write in place of this question mark? The answer is minus 411. That is our answer.